Hello everyone, welcome to the lecture series of acids and bases, and here in the lecture number 12 we are going to discuss a new subtopic, surface acidity. It is not necessary that only soluble solid substances would show acidic behavior, but also insoluble solids would exhibit acidic behavior due to their surface property. Nano-sized carbon black particles and nano or micron-sized ceramic powders, for example, silica, alumina, zeolite, etc., when they are dispersed in aqueous or in other media, they can generate acidity to the medium. This acidity can be divided into two categories, such as Lewis acidity and the Bronsted acidity. The exposed surface of a particle is different from its bulk, since it possesses so many broken bonds, which in turn possesses so many bulky or partially vacant orbitals. Hence, it acts as an electron pair acceptor. So these are the vacant sites or vacant orbitals which can accept the lone pair of the Lewis base. So this surface has acidic nature. As for example, carbon black nanoparticles are dispersed in water. The water molecules are adsorbed on the carbon surfaces, and after that, proton is released. So these water particles are getting attached on the carbon particle. These water molecules are getting attached on the carbon particle. After that, the whole electron bond pair is shifted to oxygen and the protons are released. Hence, acidity is developed. And this process can be made more effective by sending ultrasound frequency to the carbon sol in order to break the agglomerates. This is the agglomerate. So it's breaking, and agglomerates are broken into the original site, and also it enhances the surface area of the particles, definitely. The surfaces of oxides, such as that of zeolites, H-mordenite and sulfated zirconia, they contain insoluble oxyhydrogen groups, which act as Bronsted acid sites. In many cases, the acidity is very strong, much stronger even than that of sulfuric acid. Such oxides function as solid acid catalysts for a variety of reactions. For example, this reaction, where this reaction is an acid catalyzed reaction. This is isopropyl alcohol, this is zeolite. Okay, and finally, due to its acidity, this diisopropyl ether is catalytically synthesized. Now, zeolites are crystalline alumina silicates which are used as catalysts and adsorbents in the petroleum and petrochemical industry. They are formed by tetrahedrons of silicon and aluminium bonded to oxygen atom. You can see it here. And they have capacity to cationic exchange. One of the main zeolites used in industry is the fungicide or zeolite Y, which has pore aperture of about 7.4 angstrom and having cavities of 13 angstrom in diameter. Protonic zeolites are normally used in catalysis, but their acidic strength is similar to the acidity of concentrated sulfuric acid solution. On the other hand, zeolite Y is capable of activating alkanes, even at ambient temperature, showing a great reactivity. Y-type zeolites, modified by calcium, strontium, barium, lanthanum, and ammonium ions, have proper surface acidity or alkylation reaction. It could replace hydrogen fluoride as solid acid catalyst used in alkylation reaction of benzene with long straight chain monoolefins. So this is actually undergoing alkylation reaction, and this product is formed. Recently, upon reconsidering the evidences in the literature, the concept of superacidity in zeolites have been advanced. It is proposed that superacidity in zeolites may arise from the interaction of Bronsted lattice sites, this one, and extra lattice Lewisites of type this one. So these species may be formed locally upon streaming of H geolites, and it is therefore logical that the presence of such sites, if they exist, reflects the type of thermal treatment of the sample that has undergone rather than its chemical composition. Neither the activity in reactions requiring this type of sites can be explained nor be predicted in terms of overall chemical composition. The surface of gamma alumina and eta alumina are well known to differ significantly in Lewis acidity. These are different metamorphs of alumina. Surface reconstructions observed on gamma alumina and eta alumina are also qualitatively different, despite having close similarity of the bulk structures. So that's all for this lecture. Thank you. Have a nice day.